we'll move on to energy management. Everybody's familiar with that, right? I just did some energy management by turning off these lights in the front, right? Not a whole lot, but it's something. So basically what it boils down to is monitoring energy use throughout the facility to give the FM a better sense of where and how much energy is being consumed. Where is extremely important, okay, and how much is the second factor, okay, second equation to the issue, okay. So energy management, knowing how I'm using it, okay, because again, energy costs money, right, okay. So part of my energy plan or part of my energy management program is to identify when I do have a large consumptions of energy. Now, what does energy have anything to do with maintenance? Cost would be one, okay? But energy is what driving equipment, right, and components within your facility, within your building, okay? So if I had a poor maintenance program, just talking out loud, what would that do to my energy management program?
Energy consumption would go up.
Okay, absolutely, right? Because I'm not maintaining the equipment, okay, as it should be. I do not have a predictive maintenance program depending on the application of the particular piece of equipment. So absolutely. So that could be what robbing me of opportunities to save energy, okay? So let's move on here. So optimizing the facilities for the energy used, two different levels from a macro, large spectrum, down into the micro, getting down into the minute. So the first item, building obviously the overall envelope, is I want to measure and monitor the building system's performance overall. How much energy do you use? Where do I use it? Is it going to be different in July versus December? And if it's the same, where am I using it? Is it in heat or is it in the equipment that I installed? Is it for the customers? Okay, from a holistic. So part of your energy use is the entire building envelope. So getting back down to see the band of windows here in my roof, is that going to play a factor in my energy use and consumption? If I got leaky windows, right, and I got a roof that only has an R rating of 2, okay, I'm losing what? A lot of conditioned air and heated air through that. So again, energy consumption is going to be significantly more.
Do you have a modern monitoring system for your electrical systems that's separated? Like, for example, do you know how much your lighting is drawing? Do you know how much your equipment is drawing? Do you have all that so that you actually can read it out?
That's called smart metering.
Right.
Okay, and that's applying, and that's one of the lead requirements.
Right.
Okay.
Right.
So with that, you can actually apply the smart metering to your electrical systems, your electrical grids. Yeah, and you can do the same with air conditioning. And then customers. Believe it or not, the folks that are in my facility in Scottsdale, one of my biggest energy consumers are my customers. I've done everything to the building envelope to conserve as much energy as I can, but now it's my next hurdle. Okay, and that's going to be my customers. Having them buy more energy efficient equipment, or presses, or test equipment, or gear. Okay? Or turning it off. Computers. Does turning off your hard drive save energy? Or your monitor? That's always been a debate, right? It's like, well, how much energy are you really saving? Well, if you multiply that by, say, 10,000, monitors, that is a little chunk of change. But the other item is measuring. If you don't measure it, I can't determine what I'm saving in energy. So I can't go back to my population and explain that. Okay? So that's at the macro level. Now, getting back to predictive maintenance. What can I use to measure opportunities to conserve energy? A certain piece of equipment. We talked about it last week.
It's got to be
Baseline, but also I can measure any type of heat or cooling, right? Okay. So that could be infrared, right? So one of them for the building envelope, measure and monitor building systems performance, is they actually measure the building, right? Maybe 11 o'clock at night or maybe 8 o'clock in the morning to see if I'm having any type of different types of heat, okay, or cooling. Okay, so it could be around the windows or maybe around my doorways. So let's look at the micro, which is now getting into the details, which is your energy management program. So now these are the electronics within my system. So these are my controls, these are my valves, these are my dampers, my actuators, my air handling equipment. Everything that makes that building occupiable and habitable. Okay, so I'm going from the overall building envelope, getting down into the macro, which is my systems. So part of the systems, here, probably the next one here, okay, is going to be focusing on some sort of energy audit, okay, determining where my energy is going. So the first one would be lighting. These are the 4 major food groups. Okay, lighting, believe it or not, lights. Back in the 70s, it was overlit for what? To produce heat. Minimize heating requirements by using the lights in the heat load. And again, the buildings were what? Completely sealed. We talked about that last week with indoor environmental quality. The next opportunity for energy savings is your building envelope, right? Different types of windows, your R factors in your windows, single pane, dual pane, right? And of course, your HVAC systems, and then other facilities equipment that you have. Customer-owned printers could be part of that. Computers would be another one. Believe it or not, refrigerators and microwaves. Okay? I think I've got 1 refrigerator for every 50 employees, if not more, less. Everybody, there's refrigerators all over my site. And I keep bringing them in. I hate seeing the trucks come in from Spencer's. They unload 3 more refrigerators. I know they're going somewhere in my site,
well,
right?
At least they're new.
I know. But then they plug them in, right? And then one thing about folks, does anybody ever clean out their refrigerator at home? They never clean out refrigerators at home, right?
The wives
It's
don't
like-
ever clean them out. They wait for the science projects.
Science projects, yeah. Okay. So part of that is energy, right? And then, of course, it's more maintenance. So, no, back at my facility, we have clean off Fridays. So every other Friday, the janitorial staff come and they purge, Tupperware, you name it. If it's still in there, it's gone. So it's not something we want to go claim. So, again, and we do that for that reason. But again...
Did you come up with that, or...?
No, that was not my idea. Actually, that came from the janitorial company. Because again, a lot of the employees would complain that a lot of their, their ceramic pots and so on. So we posted signs saying every other Friday, please make sure. So we gave them, I think they gave them like the first 2 Fridays, they set them aside and they saved them. But after the 3rd one, but it's surprising because once you educate the folks, every Friday they're purged, they're pretty well cleaned out. Leftovers, maybe from Pizza Hut in the box still. Nobody cares about that. That's hauled out. But again, the refrigerators were getting jam-packed. Then the freezers are another story. Stuff that they just kept in there, to be frozen, but they never ate it. So again, but no, I didn't come up. That was from my janitorial staff. Okay, so again, the 4 major energy audits is lighting, envelope, HVAC systems, cooling and heating, okay, humidification and so on. And then other, which we consider the ancillary equipment, okay? Right, so now this is a typical building automation system, okay? So breaking that down, you've got your main drives, you've got your servers in this particular case here. But if you look, what they consider the back neck or the backbone, they're really handling everything from HVAC controls, okay? Multi-function sensors, maybe that are heating and cooling, maybe it's for humidification, maybe it's for client equipment. Okay, lighting control, we can turn on lights. Has anybody heard of the concept of brilliant buildings? Smart buildings would be another application to that. So you come into the building, say it's this facility, you come in on a Monday, right? You swipe your card, your employee badge, it beeps. And then immediately goes into the programming phase, and it tells you which office you're in, so it turns on your lights. It sets your thermostat. Even if you got a coffee pot, it'll turn on your coffee pot if you wanted to program it that way. So the programming is endless. You can measure just about anything. If you can measure it and put a sensor on it, you can measure it. Okay, very useful information. Okay, and of course, application devices such as thermostats, sensors. Okay, humidistats would be another one. Okay, power management, the smart meters that we were talking about, access control, who has access to certain areas of the building, central plants or versus a data center. So again, all these are combined into the building automation systems. Closed circuit TV for security, okay, access management, and who's allowed into the facility, access to certain areas of the facility. So again, you can manage this throughout a single backnet or single backbone. Okay, and of course, in the center here, you've got controllers. You can do wireless, okay? You can measure a lot of your energy consumption wireless, okay, where you don't have to have a hard line going to that particular one or a particular sensor, okay? And other items would be, again, application devices. So these devices could be, maybe it's a thermostat in a data center versus a thermostat in my general office area. Two different types of applications, two different sets of temperatures. So those are programmable, okay, within an energy management system, automation system. And you know what's cool about this, say for instance here, the closed circuit TV, say I do have an intruder, an unauthorized, right, employee that's going down to a certain hallway. Well, the automation systems can lock down all the doors, secure doors, okay, automatically, so that individuals that are not authorized cannot go any further than where they're at. And of course, with that, then security goes and escorts them down from that area. It might have been something that they weren't aware of. Okay. Other applications could be lighting, sensors. Okay. Rule of thumb: never put lighting sensors in restrooms if you don't have an emergency light. And why would you not want to do that? Have you ever been in a restroom when there's no lights in it? One, it's scary, right? Okay. The other item is pitch black. So injuries can occur, right? Okay, and just leave it at that. So typically in a restroom, any area, you're going to have an E-light. So as long as you have an E-light, then you can put the sensors in. So again, these are just some rules of thumb, okay? Sensors in hallways are very useful. Not everybody uses a hallway, especially on weekends. So after it stays dormant for, say, 15 minutes or so, the lights turn off. Same thing with auditoriums. Okay, remember we were talking about the O2 sensors and the amount of oxygen and fresh air? Okay, same application, same automation system, okay? Now, does this require maintenance? What do you think? Sure, it's going to require maintenance. Upgrades, right? Periodic testing, okay? Now, HVAC systems, purpose of an air conditioning or heating and ventilation, okay, and air conditioning systems is primarily, there's your major food groups, okay? Where does this fall in, though? Fire and life safety. I mean, I can live if I didn't have air conditioning in this room. How would life safety fall into? Mechanical systems. Good. Okay, so smoke, right? Heat. Okay, fire dampers in some applications. Some are what? By code. Sure. So the first incident where they do have any type of smoke coming into the little infrared sensors, right? And then it shuts down the units. Now, does that require maintenance? Okay, typically to your insurance carrier, you're going to have regular maintenance on these air conditioning systems. And they use that, you know, smoke in a can type. And Siemens or JCI, Johnson Controls, will provide those testings. But again, and again, the typical HVAC components, you know, you name it, grills, diffusers, anything to do with the distribution system. Okay, right up to the water chillers, which are part of your central plant. Your boiler is typically in the central plant. Okay, you got your evaporators, condenser units on your package units, going to be considered HVAC systems. Controls, piping is going to be considered part of that. Okay, heat transfer coils, your hot and cooling coils within your handlers, going to be considered part of your components for your HVAC system. So every one of these, from the dampers right up to the ductwork, require what? Some sort of PM. So the dampers inspections, that when they're properly balanced and adjusted. You ever sit in a room where they have a rattly damper? Right? One back there in the back, okay? I mean, for me talking like this, it's not very bothersome, but say we were taking the exam. You could hear everything in the room, right? So you can hear that flutter or you know, vibrate, so on and so. Yeah, okay. Piping, you know, some of them, obviously insulation, leaks, okay. And here's a cross-section of a typical air conditioning system. Typically in homes, fan coil unit from within the house, right? These are your coils, and then of course you have your condenser unit outside, which this exhausts what? The heated air, the heated refrigerant, right? Okay. But again, these are great for applications where you don't want the extra heat from within the room or within the occupant, okay? But again, part of the maintainability, being able to get to the coil. Notice what this is here? That's the condenser. That's your condenser water. Okay, so when you get to your high dew points, okay, that's going to saturate water. Hey, welcome. Thank you for the note too, by the way. Okay, so again, a lot of folks love putting condensate pumps, water pumps. Does that create another maintenance issue? Okay, So it's like, some value engineering, we don't want to put in this drain. Gosh, it's going to cost us $30,000. Well, if it's one air conditioning unit, that's one thing. Maybe we might get by with one condensate pump, right, with a maintenance plan. But say, for instance, I've got 10 of these guys, right? Maybe now that value engineering to put in that drain when the building's been built, engineer that in and install that so you don't have issues after the fact. So what's some of the maintenance requirements for this air conditioning? You got your filter replacements, right? You got your calibrations on your thermostats. Probably checking the freon once in a while. Your compressor would be another one. Okay, Megan, your compressor, okay, out in your evaporative unit. Your fan, you got a separate fan that drives your supply air, okay? And of course, all your refrigerant lines and individual controls, all those going to require a maintenance plan. Okay, and here's another cross section on a typical air conditioner. This is a rooftop package unit, okay? So here you've got what you supply air side. So this is return air. You got your hot and cold coils. This is the DX unit, so it's air cooled, right? Your refrigeration lines, okay, and this is your, in this case here, your condenser coil. And what I'm doing, I'm drawing heat out of my refrigerant. I'm exhausting it out into the atmosphere. And of course, heat pumps, when you turn on a heat pump here in Arizona, it reverse. What it does is it draws the heat from the outside into the house. That's when it gets below a certain temperature. You wake up in the morning, it's cold in here, right? Well, your heat pump is drawing out as much heat that's in the atmosphere as possible. So again, that's where you go back into your gas pack or maybe natural gas, okay? But again, every one of these components is going to require some sort of maintenance program, condenser fan inspections, okay? Again, a different type of application within your air conditioning.